end our discussion of standard deviation by looking at these kind of data sets and just kind of testing our general conceptual knowledge of the standard deviation. And so the question is, which of the two data sets would likely have a larger standard deviation? I'm going to ignore the number one because we would just calculate the two and figure it out. So that's kind of a whatever. And number 7, we don't know, unless you're a big fan of the National Football League, we don't know the speeds of these running backs or the speeds of how fast someone can run in our class. What we do know is that if you're going to be a running back in the NFL, you've got to be pretty fast. So most likely, all of the running backs in this first data set are going to run close to the same time. Like, I don't know how fast this should be, but you're not going to have guys running it in 10 minutes and guys running it in 2 minutes. They're all going to be around the 2-minute marker. Whereas if you think about students in your math class, you've got all kinds of students who may or may not be athletes, may or may not care about running or exercise or any of that. And so you could have some people that it could take an hour to run that. I mean, that's ridiculous, but whatever. It could be an hour, and some people that could do close to the NFL league. So these data values are all going to be really close to a center fast running value or speed. And then these times are going to be all over the place. Remember, standard deviation is the measurement of spread. So data set 2 will be more spread out because there's a different amounts of times, fast and short, based on what we might know about the students in our class. Now, if all of the students in the class were really slow, then they might have equal standard deviations. But we're going to assume that some people in our 130 class can run fast and some can run slow, whereas in the NFL, they could all pretty much run fast. So set 2 will have a larger standard deviation because the times will vary a lot. Let's say that. All right, let's do another one. So how about the average monthly high temperature in Chicago versus the average monthly high temperature in Los Angeles? All right, if you know anything about Chicago, they have summer where it gets really hot, and they have winter where it gets really cold. Los Angeles, I don't know a whole lot about that, but I kind of don't think they have a whole lot of winter. So for them, like, cold weather might be in the 50s and hot weather might be in the hundreds, and Chicago can go anywhere from the hundreds to the negatives, right? So Chicago will have the higher standard deviation because they have values that range from really hot to really cold. So Chicago, because the highs and lows are far apart. Okay, hopefully you're getting this basic concept of what standard deviation means. Let's do one more kind of general conceptual problem. Let's look at number 9. So a professor has 2 sections of a math course. One section, I'm going to write these things down so we can kind of not have to pull them out of the paragraph. One section had a mean of 74%. We'll call that section 1. And a standard deviation of 3.6% in terms of their score on this particular, I guess their ending class score. The other class, section 2, which met at 2 p.m. versus the 8 a.m. class, had a mean of 74%. And look at this, a standard deviation of 19.2%. So if we think about what this tells us, this class, most of our students are really close to scoring a 74%. They're about 3.6% away on average from that 70 point for all classes. If we were to calculate the C subscript V, the coefficient of variation, we would get that, 3.6 divided by 74 is equal to 0.0486 or 4.86% of the mean is the standard deviation. And when we look at this class, that's a really high spread out set of data values, meaning there's some students, well, on average, the students are 20% away from the 74%. That means there's probably a fair amount of students that failed in this class, or there might be one or two students that did really well, like in the hundreds area, and some that did really poorly. We don't quite know which one it is. Let's calculate the coefficient of variation on this one as well, just so we can see that different in percentage. This one is 0.2594. So in other words, 25.94% of the mean is the standard deviation. So these scores are really spread out.